Okay, I know you all have a lot of questions about this rubber assignment that's coming out, so I'm gonna take a little time this morning to discuss it. So you know the assignment has to do with spectroscopy, right? And your reading should help you get a good idea of what that's all about. But let's talk about spectroscopy a little now just to cover the basics. What is spectroscopy? Well, the simplest definition I can give you is that spectroscopy is the study of the interaction between matter and light. Now, visual light consists of different colors or wavelengths, which together make up what's called a spectrum, a band of colors, like you see in a rainbow. And all substances, all forms of matter, can be distinguished according to what wavelength or light they absorb or and which ones they reflect. It's like, well, every element has what we call its own spectral signature. Signature. おー、シグニチュー。If we can read the signature, we can identify the element, and that's exactly what spectroscopy does. Now, laser spectroscopy, which is a focus on your assignment, works by measuring very precisely what parts of the spectrum are absorbed by different substances. And it has application in a lot of different disciplines. And your assignment will be to choose a discipline that interests you and devise an experiment. Devise an experiment. For example, I'm gonna talk about art. I'm interested in the art, and to me, it's interesting how spectroscopy is used to analyze art. Analyze art. Let's say a museum curator comes to you with a problem. She's come across this painting that appears to be an original, let's say, a Rembrandt, and she wants to acquire it for her museum. But she's got a problem. She's not absolutely certain it's an original. And so what do you do? How do you determine whether the painting is authentic? Authentic. Okay, think about the scientific process. You've got the question, is the painting a Rembrandt? So first, you need to make a list of characteristics the painting would have to be a Rembrandt. Then you have to discover whether the painting in question has those characteristics. So first of all, first of all, you need to know the techniques Rembrandt used when he applied paint to canvas, his brushstrokes, how thickly he applied his paint, So you need to work with another historian who has expert knowledge of Rembrandt's style. You'd have to know when he created his paintings, what pigments he used. In other words, what ingredients he used to make different colors of paint. Cause the ingredients used in paintings and binding agents first varnish. Binding agents first varnish. Finish. Finishes. What have changed over time? Over time, since you were trying to verify that Rembrandt, the ingredients in the pigment would need to have been used during Rembrandt's lifetime in the 17th century. And that's where chemistry comes in. You've got to find out what's in those pigments, run their composition, and that's requires lab work, detective work really, in a word. Spectroscopy. So how do we use spectroscopy? Well, we put an infrared microscope, a spectroscope, on tiny bits of paint. And using ultraviolet light, we can see the spectral signature of each component part of the pigment. Then we compare this signature with those of a particular element like zinc or lead to determine what the pigment was made of. So you can see why this type of analysis requires a knowledge of the history of pigments, right? How and when, how and when they were made. Say we determine the pigment was made of with zinc, for example. We know the spectral signature of zinc and it matches that of the painted sample. We also know that zinc was discovered until the 18th century, and since Rembrandt lived during the 17th century, we know he couldn't have painted it. Now, spectroscopy has a very distinct advantage. 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 Advantage of a previous method of analyzing or remarks because it's not invasive. You don't have to remove big chips of paint to do your analysis, which is what the method requires. All you do is train the microscopic on tiny flakes of paint and analyze them. Now a word or two about restoration. Hmm. restoration station. Sometimes original artworks appear questionable or inauthentic because they've had so many restorers and touch-up layers to cover up. Layers to cover up damage from the paint having deteriorated over time. Well, spectroscopy can review reviews the composition of those touch-up layers too, so we can find out when they were applied. Then, if we want to undo some bad restoration attempts, we can determine what kind of process we can use to remove them to dissolve the paint and uncover the original.